This video is about operations with complex numbers. So as you may already know, some quadratic equations have imaginary, or also known as complex, number solutions, which means at some point in the problem you're taking the square root of a negative number, because that's what imaginary means. So if you're trying to solve this equation, for example, you would start by subtracting the 11. This is in vertex form, so it can be solved by square roots. 7 minus 11 is going to be negative 4. Square root both sides to get rid of the second power. And this side will be plus or minus because we always put that in front of our square roots. Negative 4 underneath. When you're simplifying the square root of negative 4, you can think about it as plus or minus the square root of negative 1 times positive 4, because the positive 4 is not the part that's causing the issue. It's the negative 1 underneath the square root that's causing it to be imaginary. The square root of 4 is just 2. And the square root of negative 1, we rewrite it as I, and it's just conventional to put the rational number first, then I. And then we have to subtract the negative 1, so it ends up being negative 1 plus or minus 2i, that minus 1 in front of the plus minus sign. And there are the two answers, the two complex number solutions to this quadratic equation. Neither one of them is a real number. They're both imaginary. We're going to dive deeper in this lesson into the properties of I, the imaginary number I. So as you know, the square root of negative 1 stands for I. If you extend things that you know about square roots, you might think of I squared as the square root of negative 1 times the square root of negative 1. Well, if we've learned anything about square roots, if you have something like the square root of 5 times the square root of 5, it ends up being the square root of 25, because of the product property. And the square root of 25 is just 5. So when you multiply a radical by itself, it ends up just being the radicand from the original one. So I squared is the same as saying root negative 1 times root negative 1, which of course is just negative 1. This equivalence is going to end up being very important. I squared is the number negative 1. So even though I is an imaginary number, I squared becomes a real number again. There are other properties of I, like in combining like terms, you could sort of treat I as if it's like the variable x. So if you had something like, actually I think that's going to be on the next slide, so let's just go forward from here. Just remember that I squared becomes real again, it's the number negative 1. Standard form of a complex number is to write it as the real component plus or minus the imaginary component, like for example 3 plus or minus 2i. And so the formula for that is a plus or minus bi. So if you ever see the instructions tell you to write your final answer as a complex number in standard form, you want to write it with the real part plus or minus the imaginary piece. Okay, here it is. So operations with complex numbers, when you're combining like terms and distributing, foiling, that kind of thing, you can treat I like the variable x for the most part. So in this first example, there's a plus sign between the two parentheses. So really, we're just combining like terms. You can drop the parentheses because none of them have a number in front that needs to be distributed. And then you're just looking for like terms to combine, and we want to write our answer in standard form for a complex number. So the 11 minus 4 comes first. The minus 10i plus 3i becomes minus 7i because I've combined like terms, and that's in standard form. The next one, I do have a minus sign to distribute, so I'm going to remove the parentheses by distributing the minus sign first, and then I want to look for like terms to combine. We're going to do the real part first, so 27 minus 13, which is 14, and then combine the two imaginary piece of terms together, and that's going to be negative 3i. So there's the next complex number in standard form. And then here we're going to have to apply that property we just talked about because we're distributing. And so 4i times negative 5 is negative 20i. But 4i times another I is going to be plus 4i squared. Now we can't leave an answer like this because it's not fully simplified. As you just learned, I squared is actually a real number. It's the number negative 1. So I've replaced the I squared with a negative 1, which simplifies to negative 20i minus 4, the real number 4. And then, of course, this is not in standard form anymore because our I squared became real. We want to put the real part first and then the imaginary part. So anytime you end up with an I squared in your final answer, you want to simplify by changing it to negative 1. This is a FOIL example with complex numbers. So just remember, if you have to expand two binomials together, you want to distribute the 8 times the negative 4, 8 times the 7i, the negative 3i times the negative 4, so you will have an imaginary piece still in the middle, And then negative 3i times positive 7i is negative 21i squared. Now we have to remember that this is the same as saying negative 21 times negative 1, and that, of course, is the same as saying plus 21. So when we simplify this, we want to combine our two real pieces, negative 32 and positive 21, which will be negative 11, and then add your two imaginary pieces together, 56i plus 12i is 64i. And that's our final answer in standard form. And then the final two examples here are very similar to when we had to rationalize the denominator when there was a square root in the denominator. So in fact, I'll show you one of those first. If you have a problem like this, you can't leave your answer with a square root in the denominator, so you'd be expected to rationalize it by multiplying the top and bottom by the conjugate. It gets rid of the square root of 3 from the bottom, and even though it complicates the top, it's still considered rationalized because the denominator doesn't have an irrational number in it. Well, if you think about I as the square root of negative 1, you'll see why these two examples also need to be rationalized. You cannot leave I in the denominator of a fraction. So you want to multiply the top and bottom by the conjugate of the denominator, which on the top will just be a FOIL problem, and it may become more complicated or equally complicated, but with different numbers. So we're going to do the top first. It'll be 6 minus 24i minus 3i plus 12i squared. We'll simplify that in a minute. The bottom becomes 1 times 1, which is 1, minus 4i plus 4i. And those are going to cancel out, which is why we used the conjugate. And then minus 16i squared. Now, as you know, both of those I squareds are going to become negative 1. So we will not have anything imaginary in this term. The numerator ends up being a 6 and a minus 12 from the end, so that's going to be a negative 6. And then the two imaginary pieces give us negative 27i. The denominator, because the minus 4i and the positive 4i canceled out, and the I squared became a negative 1, well, now the denominator is a real number. It's 1 plus 16. And then you stop, because the denominator no longer has an imaginary number in it, which was what we were trying to accomplish. 3 plus 2i, 3 plus 2i. Sometimes the top just involves distributing. That's what this example is showing. So 15 plus 2i. And the denominator will involve a FOIL. It's minus 6i plus 6i, and if you don't want to show that step because you know they'll cancel out, that's fine. Minus 4i squared. And you know that minus 4i squared is the same as saying plus 4. So this ends up being 15 plus 10i over 13. And that is all.